Math Analyzers, and welcome to your Chapter 7 exam review. We are going to talk about exponents and logs, getting ready for the questions that I ask you on your test, which will be given through Google Forms. I just want to touch base on a few really important pieces, but also to make sure that you remember that the whole answer key is available to you. So while I won't do every single question in detail, all the questions are available and you're welcome to ask me anything leading up to the Google form. Okay? So what we start with is just a review of exponents. And those are real quick, so I'll just kind of go through, give you the answers as I do it. Of course, when you are raising something to a power, you're multiplying the base times itself that many times. So this is 9 times 9 times 9, right? Or 9 cubed, 729. Done. When it's a fraction, it's top and bottom being raised to the fourth power. So 1 times 1 times 1 times 1. Well, doesn't matter how many times I do that, it's 1. On the bottom, 3 to the fourth power, 3 times 3 times 3 times 3 is 81. If you were to type that into your graphing calculator, you're going to get this. I don't want to see that answer. That makes no sense to me. You need to make sure you are actually doing top and bottom this way, okay? I didn't ask these on your test, but if I were to, that's what we would be looking for. The difference between 5 and 6. The whole thing on number 6 is being raised to the 0 power. So the whole thing is 1 versus over here, only x is being raised to the 0 power. So only the x is 1. 4 times 1 is still 4. So you have to be careful about what's being raised to the 0 power. When you are raising to negative powers, if it's a fraction, it flips the fraction over. That's the negative piece. And then it squares top and bottom. If it's an integer being raised to a negative power, it flips it in the base and then squares it. So you get your denominator raised to that power. If your exponent is a fraction, it's really a radical, where the bottom number is the index and the top number is raising that base to that power. And so in this case, it's 36 to the first power is 36, and I'm taking the square root of 36 to get 6. In this case, I'm taking the fourth root of 16. So what times what times what times what times what, sorry, 4 times, gave me 16 in the first place, and then cubing that. So the fourth root of 16 is 2. 2 cubed is 8. Excuse me. Okay, that's where I would get that from. On your test, I am going to ask you to graph one exponential. It is going to be similar to this one. Or no, I'm sorry. I ask you to graph an exponential on its own. And then I ask you to graph an exponential with a logarithmic to show the inverse relationship between the two. So this is part of the inverse relationship one I'm going to ask. Just kind of keep in mind that the exponent is your x. So that means that's what changes throughout. Okay, and I can go this far as like getting that in there. But what you need to remember is we all have this memorized because we have been doing this one so many times. That specific one I did in your notes just now in lesson 9 as well, right? So make sure you show each point that you're graphing. Make sure you connect, make sure you put arrows at each end, make sure you label the equation, and make sure you label the asymptote. The asymptote is part of the graph. It has to be on there too, okay? So let's get these points on here. And then when we're going this direction, right, half, 1/4, 1/8, when you do your arrow here, make sure to show it straight. Do not let it go below y equals 0. And again, because This is your asymptote. This is your invisible barrier you cannot touch or cross. So please make sure that is labeled and then make sure this is labeled. Okay? That's something you really want to make sure is the case. Now, this is part of your test. And when you do these on your test, there's a section where you can put an answer in, but it's because it's not required, where I'm grading this is in your work. So when you take the picture and upload this, I need to see this change because there really isn't a good way to do the logarithm in the answer spot. So again, express the exponent as a log. It's log base 2 to 8 equals 3. Log base 5 to 25 equals 2 because it's 5 to what power is 25. That's your answer to a log. This is log base 3 of 1/27 equals -3. And this is the only spot you're allowed to have that negative because this base right here needs to be a number greater than 1. This answer right here can be 1 or higher. Okay, but this is where you can have a negative because you can have a negative exponent, but you can't have a negative base and you can't have a negative answer. Here, log base 7 of 49 is 2 because 7 to the second power is 49. So that's the switch you want to be doing. Now, back the other direction, logs 2 exponents, logs 2 exponential form. So 2 to the 4th power is 16. 3 to the 3rd power is 27. 4 to the -4th power is 1/256th. And 5 to the 3rd power is 125. Okay. If you have an ln, which of course I don't have here, so the likelihood of that happening on your test is pretty low, right? But if you have an ln 15 like this, and you're changing it back into exponential form, it's e to the, right? Oh, excuse me, I have to set it equal to something, so I'm just going to say x. Okay. E to the x power is 15. Okay. That's what the base change is. For ln, the base is e. Okay. Whatever this answer is, that's the exponent. So that's how you would change a natural log back. Notice I didn't give you a natural log in those sections, so I'm probably not going to ask that on the test. Just throwing that out there. But I do specifically ask in this section that you have to show me change of base, then show me the answer rounded to the nearest thousandth. So you have to show me this step right here, which is log 63 divided by log 4. The answer goes on top, the base goes on the bottom, and then plug it into your graphing calculator. I was using my my actual physical graphing calculator instead of my computer one earlier. But you would just press log 63 and then end parenthesis divided by log 4 and then end parenthesis. Round to the nearest thousandth is 3 decimal places. So this rounds up to 9, which means that rounds, no, just up to 9. We're good. Phew. Thought I was going to have to round a whole bunch up, but I don't. 2.989. There you go. I'll do one more. You need to show the change of base. So you've got to actually show the formula being used, which is, again, log 71 divided by log 9. And then you type it into your graphing calculator to give me to the nearest thousandth. So log 71 divided by log 9. There we go. Well, 1.940. If I ask you for thousandth, you can still put that 0 there. Okay. I believe you can put the final answer there, but only way to get full credit is to show me this middle step because you do need to have the formula memorized for change of base. Okay. So you need to know how to change a log of any base into a log base 10 so that you can use your graphing calculator. Now, these guys, remember, if your base and the exponent that has the log in it has the same base on that log. Those pieces can cancel out and just your answer remains. So 11 raised to log base 11 cancels out. What's the final answer? 121. 6 raised to log base 6 cancels out. What's the final result? 216. E raised to ln cancels out. What's the answer? 15. But, oh, this one cancels too. 3 raised to log base 3 cancels, leaves me with 81. But 9 raised to log base 3 does not automatically cancel out. So the 9 needs to become 3 raised to the second power. And then we already had the exponent log base 3 to 10. The 3 and log base 3 cancel, but this 2, because of the property rules, is now the exponent on 10. So the remainder here is 10 squared, which is 100. So just watch to make sure those bases are the same before you do the auto cancel. Because if they're not the same, you need to make them the same by changing the space down to match the space. Just like we did in the exponential equations. So when you see these simplify using the product rule on your exam, I actually made the 2 factored pieces that I'm about to do here. So I gave those to you in the test. So this would say log base 2 to 3 times 5 in here, and then you expand it out, okay? So this is getting expanded out to log base 2 to 3 plus log base 2 to 5, okay? Because the product rule, meaning the 2 factors that make 15, means to add the 2 logs together. So the values of each of these logs actually add up to the whole value of this. Okay, so the product rule means to add between. So this one would be log base 3, 4 plus log base 3 to 5, because there's 2 products of 20. There's 2 products of 20. Okay? Then quotient rule would be subtracting, it's the opposite, right? So log base 4 of 4 minus log base 4 of 13. If you have something like log base 4 to 4, so the base and the answer are the same, that needs to be replaced with the integer that it's equivalent to, which is the 1. So this is actually equal to 1, because 4 to the what power is 4? 4 to the first power. So if you run into that, you have to make that change. If you don't run into that, then who cares? Okay, then leave it. But if you run into being able to change your log by replacing it with an integer value, you have to do that. So same here, where you get log base 3 of 9 minus log base 3 of 2. Log base 3 of 9 is equivalent to 2, because 3 to the what power gives me 9? 3 squared. So this replaces it. This one over here can't be replaced. That's it. This is your final answer right here. Okay, so notice how if I can simplify one of the logs by changing it back into an integer, I do that. Okay, it's just like how you can't leave a perfect square factor under a radical. You change it. You don't leave radical 49 hanging out. It's 7. So do it. Same here. Okay, same kind of idea here. I guess none of these do it, but I'll do this one right here. So if your answer is raised to a power, it's just 8 of those. It's 8 log base 2 to the 7s. Okay. And again, if you could change this, you would do it. In that case, I can't, so I won't. Okay. There are 6 log base 2 to 5s. Okay. And again, I can't change that particular one. When you see these, we simplify them into one log base. So if there's one that's already expanded, simplify it down to one log base. Like here, there's the same log base of 10. There's subtraction between them. So this is a quotient. Here, only the log of 4 is being raised to the second power. So when I create that one log base of 10, it's 4 squared divided by 5 that goes in here. If you have multiples, you take care of all the multiples. So the log of 5 is being raised to the fourth power. So I'll put that here. Then I'm adding here and subtracting here. So one log base gets written. It's 5 to the fourth power times 2 over 3 because we've got that subtraction going on with those. Oops. How about we need to see that? There we go. Now, why did we do all this log stuff? Because we might run into equations where this would be really handy. And equations like 45 to 48, these are the types of equations you'll see on the test. You will also see exponential equations, which I'll show you in a second. But the rules here apply, right? What's the base on both of these logs? It's 12. Well, then I'm going to put those up in the exponent so that I can cancel those logs out. So now I've just put all this stuff up in the exponent. 12 is the exponent base. Log base 12 is the exponent. That cancels out and leaves me this x squared plus 27. Over on this side of the equal sign, same deal. 12 is the base of the exponent. I'm raised to log to the 12. They cancel. 10x plus 3 is left. Now, bring that stuff over to the other side of the equal sign. Because you've got an x squared, it all goes on one side. So it's minus 10x and then subtract 3, so plus 24 equals 0. X minus 4 and x minus 6. So what are my answers for x? 4 and 6. Both keep my value here positive, so both are the answers. And in this section, while I require work for the full answer, I do ask you to put your answers for X in French curly braces for the Google form to grade that part. And then I'll just verify that you've got all your work that supports that answer. If you have an extraneous root, you got to throw it out. With this one, because you've got the 4 in front, subtract that guy off first. So you end up with a 0 over here. So log base 9 of x minus 1 equals 0. Okay, 2 ways you can do this. You could change all this back into exponential form. So 9 to the 0 power equals x minus 1. That's what I would do, because 9 to the 0 power is 1. And add 1 to both sides, x equals 2. Or you could say raise them both to 9. Put both of them in exponents. The base is 9. That now cancels. 9 to the 0 is still 1. You still end up with this equation right here. If there's a number in front like this, divide it off first. You got to get that log alone first. And I'm actually going to treat this one in exactly the same manner I just did the last one. Look, you can change that back into exponential form so easily, right? It's 9 to the first power is x plus 8. Well, 9 to the first power is 9. Subtract 8 from both sides, x equals 1. Oh, sorry. That's how we're putting answers in to Google form. My bad. Both of these have base 10. So since you have logs on both sides, raise them up and cancel. When you got logs on both sides, you have to do it that way. When you only have logs on one side, you could change it back into exponential form like I did here and here. So x plus 9 is left, and it equals 4x. That's what ends up being left. Subtract x. 9 equals 3x, and divide both sides by 3, so x equals 3. And again, I did it. I need French curly braces. There we go. If you have an extraneous root, don't include it in the French curly braces. These both happen to work and keep this positive, so I got to keep them both. But if they didn't, I'd have to reject. Now, when you run into these, okay, just use that by changing it into a log. So now these are exponential equations where you're not going to be able to get the same base. So just say, this is the opposite of what I was just doing. Put it into logarithm form. Now use the change of base formula. And any of these that you run into is round to the nearest thousandth. So this would be log 51 divided by log 6 Round to the nearest thousand, 3 decimal places, so 2.194. There you go. That's what you would enter in the Google form because I'm asking you to round to the nearest thousandth anyway. Okay, one more time. Not going to be able to get the same base on these. Okay, so I just change it into a logarithm. The base of the exponent is the base on the log. The answer to the exponent is the number in the log. And then the answer to the log is the exponent itself. That's how I do that switch. Now use change of base formula so you can plug that straight into your graphing calculator. The log base is the bottom. Do it that way and then plug it in. And go backwards and see how quick this is. Just go 3. Yep. So I'm just going back to the old question that I had, doing this, changing it, right? 2.402. So x equals 2.402. And again, yep. And again, type that into French curly braces in the Google form. Now, on your test, I am going to ask you to graph a logarithm on its own. Okay, so that's one of the questions that I will ask at the end for graphing. So here is a blank sheet of paper underneath. Here is a logarithmic question I might ask you to graph on its own, which would be right here. Okay, just plug it into your graphing calculator. Don't even worry about looking at the equation and trying to find the asymptote and all that jazz. Just go right here and go to y equals and say, if I have an 84, I can say, okay, under math and way down at A, I have this log base here where I can put 2 in the base and I can arrow into the inside of the parentheses to put this x plus 3. And then I can arrow out of the parentheses to put the plus 4. Now the plus 4 just moves it up on the y-axis. So that's what's happening there. And then the 3 scooched it over and essentially told me that x equals -3 is my asymptote. So 1, 2, 3, x equals -3 is my asymptote right here. I'll be able to see that on the table real quick, and I'll show you that in a sec. But that just then gives me my asymptote. Okay, that's giving me my asymptote and just helping me out a little bit as far as that goes. I said the y-intercept, but I didn't mean that. I'm so sorry. It moved the whole graph up for not necessarily giving me that y-intercept. Let's see the table. And I just want to show you that if I go up here, the error is at x equals -3. That's because that's the asymptote. So that's how I know where the asymptote lies based on where is my first error message on my graphing calculator. So x value of -3 is my first error. And then I look for the integer points to graph. So -2, 4, -1, 5. My next one isn't until 1, 6. So no 0. So I go to 1, 6. Sorry, I tried to write 6 in the x and it's the 1. That's the x value. And then 5, 7. Probably 5, 7 is the last integer point because I've got 4 integer points. That's an awful lot. I can't typically fit that many integer points on the graph. Oh, yeah. Oh, yeah. 13, 8. I don't have 13 across on x. So 13, 8 being the next one that is available to me, that's a little bit too far off of the graph. So graph the integer points you can fit. -2, 4. -1, 5. We don't have one for 0, so 1, 6. And then 5, 7. 1, 2, 3, 4, 5, 6, 7. Let's try again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I really wanted to count that x, and that's not where it goes. Stop at the last point that fits, just like that. That's actually a lot of points that we got to fit for an exponential, or excuse me, for a logarithmic. And then, of course, we're heading towards the exponent, but we're not going to actually touch or cross the x equals 3 asymptote. So we're heading towards it, but not going to touch or cross it. If you just kind of indicate that we're heading towards it, that's plenty. Don't try to go overboard. Okay. Because if you go too far with it, then and don't do it exactly correct, I have to mark you off, and I don't want to do that. You have to label the asymptote, you have to label the equation. There you go. Now, if you don't have an 84 or are not using this app the way that I am, the other way you can enter this is using the change of base formula. But you have to remember that you have to do the change of base, and then that +4 is off to the side. So when you go to enter this, if you're wanting to use change of base, right, it's log of x plus 3 divided by log of 2, the base, and then this +4 is off to the side, and this whole thing needs to be in parentheses. So you're going to have to be careful if that's what you choose to use. Okay? I'm going to have to be careful about that. So front parenthesis, log of x plus 3. Okay, so now that's just ending that. Now divide by the log of 2, and that ends that particular piece. Now, one more set of end parentheses ends that whole, encompasses that whole log. Now you can put +4 at the end. Ooh, how about the plus first? +4 at the end, and it's still the same thing that I have in Y1. And see, it's showing you that it's the same thing by graphing straight over it. All the points are exactly matched. Okay, so if you don't have an 84, you can still do this, is all I'm saying. You just have to use your change of base formula more often. Okay, the 84 just updated that particular function by adding the log base piece to it. The full answer key for this is, of course, posted in the assignment so that you can see it and in the answer keys for chapter 7. But again, I've kind of gone through and shown you the highlights of the pieces. And that's it. Guys, I'll be seeing you soon. Have fun with this. Good luck on the test. Bye.